Hello everyone. As we have started the exam of 2014 final exam. So in this session, we will see about part 2, which is a short answer. So please follow my channel. Please like, share, and comment on the video lectures. Your comment makes me to do more on this area. So the first question is, it says let U is the set containing 1, 2, 3, be the universal set, and X and Y be an element in U. So the truth value of for all X, there exists Y, X squared plus 2Y less than 10. Less than 10. So I did that we have, let's remember some of the concepts related to this one. Okay. So some of the concepts related to existential and universal quantifiers when they are coming together is when they're coming together is there are 4 possible ways for all X, for all X, for all Y, which means for every choice of X, every choice of Y satisfies the condition. And the other one is there exists X for all Y, for all Y. There exists X for all Y, which means that for we can find a unique X for all Y. We can find a unique X for all Y satisfying the property of P. And the last one is for all X, for all X, for all X, there exists Y. There exists Y. For all X, there exists Y. For all X, there exists a corresponding one such element. So the truth value for this statement is false. And the next one is let X is an element of natural numbers, and if the GCF of X and 24 is 8, and LCM of X and 24 is 120, then what's X? Now we have GCF, the greatest common factor, and the least common multiple. Least common multiple, the greatest common factor and the least common multiple. The greatest common factor and the least common multiple. Now we have one property in relation to this, the greatest common factor and least common multiple. So the GCF of 2 numbers, X and Y, the GCF of X and Y, the GCF of X and Y times the LCM of X comma Y, X comma Y is always equal to X times Y, is always equal to X times Y. So we have given the GCF, which is 8, and its LCM is times 24 times 24, which is equal to the first number is x times this, the other number is 24. So when we are dividing it by 24, sorry, this one is 120. The LCM is 120. The LCM is 120. So 8 times 120, which is equal to 2x times 24. So dividing by 24, with dividing by 24, we obtain the value of x. We obtain the value of x. So 24 by 24 is cancelled. 8, 1 by 8, which we get 3. So 120 divided by 3 is 40. So the value of x is 40. The value of x is 40. So the value of x is here is 40 is the exact solution for this question. And the next question is if a number of elements, if the number of elements of a set A is n, then the number of possible relations on a set A, the number of possible relations. So when we are telling about a relation comes from the Cartesian product of two sets. The Cartesian product of two sets assumes that we have two sets A and set B. Assumes that we have A and set B, and assumes that A has k elements and B has m elements. B has m elements. Then we have A cross B, the number of elements. The number of elements of A cross B. The number of elements of A cross B. A cross B is the number of elements of A cross B is which is equal to number of elements of A, or times B, number of elements of A times number of elements of B times number of elements of B. So which is the number of elements in the Cartesian product of A cross B. So the relation formed by this sets A and B, is to the power of number of elements of A, times number of elements of B, number of elements of B, which is this one. So if A is a set having n elements, so when we come to our question, the number of elements of A, number of elements of A times number of elements of A to the power of number of elements of A times number of elements of A, which is the same as to the power of n times n, which is the same as to the power of n square, which is the same as to the power of n square. So the number of possible relations is to the power of n square, the number of relations formed by set A containing n elements. The next question is let A be 4, 6, 8, and define the relation R on xy says that A an element of relation if x is divided by. So the relation R is formed. The set of ordered pairs xy, the set of ordered pairs xy says that x divides y. So the relation is formed in such a way. X divides y. So what? Before finding the inverse relation, let's find R first. So by ordering those elements, 6, this is 4. 4 is just 4. 4 divides 4. and the other one 6 divided 6 clearly, right? And 8 divides 4, 8 divides 4, 8 divides 4, and so sorry, what's left here is 4 divides 8, 4 divides 8 is left, 4 divides 8 is left, and the last one is 8 divides 8, 8 divides 8. So these are the relation R. These are the relation R. These are the relation R. Then what's R inverse? What's R inverse now? R inverse is just ordering, changing the order of disordered pairs into A into B, B into A. And the relation R inverse is Yx says that Yx says that xy is an element of the relation R, an element of the relation. Yx says that xy is an element of the relation. So which is 4 itself, and 6 is the one, and the other one 8 4, and the last one is 8 is the last one. 8 is the last one. So this is R inverse. This is R inverse. This is R inverse. The fifth question is, given the set S, Y says that Y is equal to 1 over n minus 1, where n is non-zero integer, where n is non-zero integer, which is an integer different from 0. Instead different from 0, then the list, the global, the greatest lower bound of S and least upper bound of S is asked. So we have the greatest lower bound and least upper bound. Least upper bound. The greatest lower bound is an element which is the greatest one from the lower bounds. The greatest one from the lower bounds is the greatest lower bound, and the least upper bound is an upper bound. There is an upper bound set from those upper bounds. The minimum one or the smallest one is said to be the least upper bound. The smallest one is said to be the least upper bound. Now, y which is equal to 1 over n minus 1 is given. 1 over n minus 1 is given. So when n is equal to 1, when n is equal to 1, y becomes 1 minus 1, which is equal to 0. Y obtains 0. And when n is equal to minus 1, when n is equal to minus 1, y which is equal to minus 1 minus 1, which is equal to minus 2. So when n is equal to plus or minus infinity, y which is equal to 1 over n minus 1, 1 over n minus 1. When n goes to positive or negative infinity, this number goes to 0, so that it get minus 1. So from these properties, you can see that the smallest element is the smallest element is this one, smallest element. So the greatest lower bound will be this one, and the biggest, the big element is the least upper bound. The least upper bound is 0. The least upper bound is 0. So the greatest lower bound is minus 2, and the least upper bound is 0. The least upper bound is 0 for this sequence. The other one is let f of x is equal to x minus 1 over x plus 1 and g of x is equal to 1 over x be the real value function. Then g of f of minus 1 over 2 is. Now first let's determine g of f of x. Let's first determine g of f of x first. So which is the same as g of f of x is the same as 1 over g f of x, 1 over f of x, which is the same as 1 over f of x, which is the same as 1 over f of x, which is equal to 1 over x minus 1 over x plus 1, So we can write this one as, x plus 1 over x plus 1 over x minus 1. You can write x plus 1 over x minus 1. So g of f of minus 1 over 2, is equal to minus 1 over 2 plus 1 over minus 1 over 2 minus 1 over 2 minus 1 over 2 minus 1 minus 1 over 2 minus 1. So which is the same as minus 1 over 2 plus 1 is 1 over 2 over minus 1 over 2 minus 1 is minus 3 over 2 So the value for this one is minus 1 over 3. Minus 1 over c is the value of that. So which is minus 1 over 3 is the solution. The other one is let z be given 1 minus I over minus radical 3 plus I. Then what is the modulus of z and the argument of z? So now let's see this one. Z is given as z1 over z2, z1 over z2, z1 over z2, z1 over z2. Now, depending on the property of the modulus, which is equal to the modulus of z, which is equal to the modulus of z1 over z2, z1 over z2, which is the modulus of z1 over z2, which is by the property of a modulus, which is the modulus of the quotient is the quotient of the modulus, which is the modulus of z1, over the modulus of z2, which is the modulus of z1, the modulus of z2. So which is the same as the modulus of z1 is the square root of 2, over the modulus of z2 is which is the square root of 4, which is the square root of 4. So which is the same as square root of 2 over 2, and the argument, which is the square root of 2 over 2 is modulus of z1, the argument of z, and argument of z is the same as argument of the quotient, argument of z1 over z2, argument of z1 over z2. So argument of z1 over z2, which is by the property of an argument, which is argument of z1, minus argument of argument of z2, argument of z2, argument of z1, or minus argument of z2, which is argument is obtained by tan inverse of which is tan inverse of y over x, tan inverse of y over x, where y here is minus 1 over minus 1 over 1 minus tan inverse of and this one is 1 over radical 3, 1 over minus radical 3, 1 over minus radical 3, 1 over minus radical 3. Clearly, 1 plus minus I is found in the fourth quadrant, and 1 plus I is found in the fourth quadrant, and radical 3 minus plus I is found in the second quadrant. It's found in the second quadrant. If so, 1 plus I is found in the fourth quadrant, which is minus pi over 4 is the angle for this one, the argument for this one, minus tan inverse of 1 over radical 3, which is just, we can find just like this one, tan inverse of 1 over radical 3, which means that 1 here we have on the opposite, and radical 3 here we will have on the adjacent. So the hypotenuse will be 2. So what is sine theta, which is 1 over 2, sine theta, which is sine theta. If we take this one as theta, opposite over theta is equal to 1 over 2. So what's theta? Theta becomes what? Theta becomes pi over 30 degree, which is pi over 6, which is pi over 6. Therefore, this is the first quadrant, but it's found in the second quadrant. Therefore, 30 degree we have here. 30 degree. We have here 30 degree. Then we need to find here. We have here 30 degrees. So this one is 60, and this one is 60. 120 plus 30 is 150. 150. We need this one. We need this angle. We are looking this angle, which is 150. 150 degree. 150 degree into radian is, we can multiply pi over 180. Pi over 180. This one by this one, 0 by 0 is cancelled. By 3 is 5, and by 3 is 6. By 3 is, so 5 pi over 6, which is 5 pi over 6. 5 pi over 6 is obtained. So taking theorem as common, which is minus 3 pi. Minus 3 pi is here. Minus 10 pi, which is 10 pi, which is 10 pi. So which is equal to minus 13 pi over 12. But the argument of the argument is always between pi, pi less than or equal to argument less than pi. It should be always between this one. So which is greater than that, which is greater than this one, which is less than this one. So we should change that one into this form, so that 2 pi minus 13 pi over 12, which is taking 12 as common, which is 24 pi minus 13 pi, 24 pi minus 13 pi over 12, which is almost 11 pi over 12. 11 pi over 12. So this is the exact solution. So the argument is 11 pi over 12. 11 pi over 12 is the argument of this complex number. And the next one is the next one is f of x is equal to, if g of x is equal to this one and g of gof is this one, then what's f of x? So clearly we can find this one. We can find this one, f of x, g of x is this one, and f of x, g of x is given. So g of f of x is given just like this one, 2x squared minus 4x plus 7, which is this one. So g is g of but g of f of x is this one also. G of f of x is also this one. Since g is given, which is the same as f of x minus 2, f of x minus 2, which is equal to 2x squared minus 4x plus 7. So which is the same as f of x is equal to 2x squared minus 4x plus 7 plus 2. So which is equal to 2x squared minus 4x plus 9 is f of x. So this is the f of x value, which is f of x value, this one. I think we have finished the second section of which is about the blank space. So on the next section, we will see the workout part. Thank you for following me. Give me your comments. Please share, like, subscribe my channel.